Okay, we're good? Hello, everyone. Welcome. I'm Chris Hartzell. Thanks for coming tonight. And welcome to all the folks on Facebook. And we're happy to have you with us. The Evanston History Center is grateful to be in this historic house, which was the home of Charles Dawes, who was vice president. It's funny, it feels funny saying this. I give so many tours, and I'm like, come on, you guys know this, right? Under Calvin Coolidge. And just so you know, if you don't, we do tours Thursday through Sunday in the afternoon. So we would love to have you come back and take a tour. And we also recognize that the land this house is on has a rich history that goes way farther back than Charles Dawes. This home stands on the unceded ancestral lands of the Potawatomi, Ojibwe, and Odawa peoples. We honor this history and we remember it as we use this house. And even though we are based in the home of one historic Evanstonian, we take seriously our role in making sure different stories and perspectives are valued, and that through exploration and dialogue, we continue learning. It's important to us at the History Center to document and share the many aspects of the places, people, and movements that have shaped our city. And for the topic tonight, at the junction of Earth Week and May Preservation Month, right? We've got a great topic that kind of straddles both of them, sustainability and historic architecture, which is we're all about here, but Ellen's going to tell you all about it. So we're pleased to have with us Ellen Stoner, who is the founding principal and a preservation architect at AltusWorks Architects. I know I've got this all typed up and I've got your bio, but I just have to say that we've worked with AltusWorks since 2010. It's been a great collaboration and we're so appreciative of everything you guys have done for us here. And so I'll go on a little bit about Ellen's qualifications. She's AIA, and I have no idea what CXA plus BE means.
That's a building envelope commissioning agent.
Oh, that's interesting. Good to know. And LEED AP, which is also good. As the founder of and preservation architect at AltusWorks, Ellen leads a team of diverse professionals in the holistic approach to restoration and rehabilitation of existing and historic structures. Through Ellen's profound understanding of historic and new building materials, technologies, and systems, AltusWorks excels at problem solving related to the complexities of working in existing and historic structures. Absolutely true. With such expertise, Ellen facilitates the implementation of a variety of projects from facility assessments and program management to additions, building renovation, restoration, envelope repair, and adaptive reuse. I have, as I said, had the pleasure to work with Ellen and her talented team of architects who, and of the many experts in all the related fields that go into maintaining a historic structure. From compliance with National Trust requirements to systems and sustainability experts to masonry, the list goes on and on. We've been through many projects together. Ellen, thank you. I was going to make a joke about the blower door test, but I see you've got it in your talk. So, because we have a fully passive house on Housewalk this year that we're really excited about. They were bragging about how, they have the same, air exchange as a submarine. And I'm like, oh, you should have been there when we did the blower door test at the Dawes House, because those guys all lost their minds because it was just like a sieve. And all the masonry work around the house and reinforcing the coach house floor, rebuilding the back porch, it goes on and on. We can always count on Ellen and her team to manage each project at the highest level of expertise and reliability. So welcome, Ellen. Thank you very much for coming tonight. We'll look forward to hearing your talk. Thanks.
Ellen, you got it, so there's no red light.
I think I turned it off. There's no lights.
Okay.
Yeah.
There you go.
Okay. Thank you. Thank you, Chris, for that wonderful, wonderful introduction. We've had a fantastic time working with you and your crew here at the Dawes House. It's a really fantastic facility offering great history and all the tours related. As I get up my notes. So thank you all for coming tonight. So tonight I'm going to really focus on sustainable preservation. This is something that's very close to my heart because it's super important in order for us to maintain our historic buildings, keep them relevant. We do need to continue to be sustainable, bring them up to meet current codes, and to really make them viable assets for the owners and the communities that they serve. So I'd like to jump right into Here we go. I think we all know and have heard that the greenest building is the one that's already been built. And that all has to do with embodied carbon, right? It takes a lot of energy and resources to build houses, buildings of all types. So it's really important that we understand that embodied carbon. And that's been a big discussion around sustainability. However, once you get into historic buildings, it's more about operational carbon and how to maintain those buildings so that you're continuing to reduce their footprint and to, approach net zero, because otherwise we won't, unfortunately, see these beautiful structures to continue in our future. So as we look at what is sustainable preservation, it is really a relationship between historic preservation and environmental sustainability. Those things go hand in hand. And we want to make sure that relationship continues to build. And we do that through building science. So it's super important that we understand how our buildings are functioning so that we can really address the issues at hand and make them as energy efficient as possible and as welcoming to our community. So we really want to identify opportunities where sustainability can be introduced. And then also while really protecting the historic integrity of the building and making sure that they continue on into the future. So as we look at sustainable preservation, it really is an offspring from the main sustainable movement within the country. So in 1993, the U.S. Green Building Council was founded, and that was really the beginning of the sustainable movement. And I got to say, that was the beginning of my career. So I've been able to grow up with this whole program. And so in 2003, they put in place a rating system, the LEED rating system, Leadership in Energy and Environmental Design. And that was really a way to force the market into building sustainable buildings. It forced codes to be updated in order to meet those requirements and to really challenge people to start protecting our world. And the APT, which is the Association of Preservation Technology, which really is the guide for all restoration aspects here in the States. They started their own committee in 2004 to really start education and dialogue among professionals so that we were being really forward-thinking and applying these concepts to all historic buildings. So then in 2006, the National Trust came out with their sustainable statement, really, further bolstering this attempt to make historic buildings sustainable. And at the same time, the Kresge Foundation was very much invested in in sustainability, but they were the first foundation that gave out funds to really move sustainability forward. And to demonstrate that it could be used with historic buildings, they built their headquarters in 2006 using these barns as part of that complex. And then they were able to achieve the highest rating of LEED, which is LEED Platinum in 2008. So they set a very great precedent for all of us to be looking forward to. So as we get into what is the importance of preservation and why should we be doing it, it is really because, we're here to celebrate what humans have accomplished, what we contribute to the world, what we've discovered, the individuals that have brought that forward, like we see here with Mr. Dawes. We also want to exemplify our innovation and design and make sure that these systems and facilities that we've built are really demonstrating what we've accomplished in our lives. And lastly, to really solidify community in and around what makes our disposable world we live in to feel more permanent through a layering and depth of important historic structures. So based on all that background, when we dive into a historic building, we take a process to really understand how it's performing so that we can identify where are the sustainable features that we can introduce, how can we really improve how that building's functioning so it can continue to service all its people. And so when we have the opportunity, we dive into old drawings just like this to really see how things are put together, what was the technology at the time that the building was built. We will do research to find similar drawings if the structure we're working on doesn't have drawings. And then we will really look at what were they doing at that time period and what was the technology. How is it aging with time and how is it failing or how is it succeeding and what can we learn from it? So as we look at those type of approaches, we get into our assessment and evaluation of the structures. So we start with forensic work, which is illustrated here on the left. This was actually a site visit of my staff out at the Museum of Science and Industry as we were restoring one of the beautiful terracotta domes. And so we were digging into the walls themselves to see how those things were put together, how were they anchored, where was the water coming through, what type of damage was being caused. And we recorded all that information. Because if you don't understand what the cause of the problem is, you can't fix it. And then on the right is an example of the blower door test that Chris had mentioned. And this is at a different facility, but it's the same concept where we pressurized the building and then we were able to measure how much air was being forced through the envelope. And we were also able to identify where that was happening. So we did that either through using a pencil test, smoke pencil test, which basically is like having a little fire in your hand and you see where the smoke goes, and that tells you how it's moving in and out of the building. And we also were able to use thermal imaging to understand where things were hot and cold, and you could see where the air was blowing out of the building. So from understanding those kind of site conditions, then we got into the use of more technology, such as what they call WOLFI, which is a German-based analytical program, along with Therm. And both of these are 3D modeling components. And so we will first start by building a model, and this is of Banging Gavel Brewery, which is down in Tinley Park. It is a National Register historic property that we converted from an apartment building into a brewery. And putting together this model of the building, we're able to run an energy model with our engineers where they can tell us, looking at the thermal performance of the walls and the windows, what size equipment they need. They can also tell us if we change the windows or we re-insulate the attic or we stop some air leakage, that can then reduce the size of the new mechanical equipment going into the building, which ultimately saves the owner money. And so we will look at that. And then as we get into the Therm, which is on the right, that shows us how those window and exterior wall components are functioning, how thermally effective they are. And where we see the red is really where they are failing. And we want to make sure we're not having any condensation issues. So we want to make sure there's a continuity of a very nice, thick insulative value. And then always we look at windows. So this window on the left is actually here from the Dawes House. We've not had to do any window restoration. The windows were worked on in the early 90s. But when we first looked at them, they were in very good shape. They had been restored in the early 90s. And they were performing relatively well because they have storm windows on them. But what we do with windows is we really want to look at how they're functioning and whether they need to be insulated and how are they detailed into the wall, right? Because with new buildings, there's very much an air and vapor barrier that wraps the whole building, is tied into the windows, tied into the roofs, so that nothing leaks. And we know with old buildings, they leak wherever there's a penetration. And that's generally at windows. It's where the chimneys are, it's where the roofs and the walls meet, it's where those intersections of systems occur. And so we look at that to see where are these leaking and how can they be improved. It could be through weather stripping, it could be through insulating around the windows, it could be from air sealing, just with some sealant work. All those are super effective ways to really reduce air movement because we know air carries water with it, it carries air vapor with it, and that will settle and condense within the walls, and that's when we start having problems. So we also want to look, you can see this is the Dawes House, but we want to make sure that we look at all the passive systems that are integral to the building. And so we will look at things such as the orientation of the building, because they were built before we had all air conditioning and fancy forced air systems. Buildings were built to perform passively because they took advantage of the climate that they existed within. And so we want to make sure we understand the siting of the buildings to see how they use those natural components. We look at ventilation, or I should say natural ventilation, shared light, as well as overhangs, which can act as brise-soleils or sun shading, and other devices that are inherent to the design of the building. We can enhance those elements by understanding what they are. So as we get into mechanical systems, and how do new mechanical systems integrate with historic buildings? So as you know, I've put together a smattering of kind of the top of the line sustainable systems that are now being introduced into buildings, both existing buildings and new. So we have wind turbines, PVs, the photovoltaics. We also have high efficiency boilers, which those are actually old boilers, but they are beautiful. We have geothermal systems, which we put in here, as well as we have more of a combined electric and a standard and electric system, which are these air-cooled chillers. But all of these bring in a great level of sustainability, cost effectiveness, and some of them are actually quite visually unobtrusive to the building. And that's what we always want to do with historic structures. So we really look closely at this, particularly as people are moving towards net zero goals for all their buildings, historic or not. So here we are at the Dawes House. So I thought we would talk a little bit about what we've done here over the last 15 years, which is a little amazing for me to think of. But it's a beautiful home, and we're really happy to be part of this process. So when we first started in 2010, we were tasked with doing a comprehensive facility assessment. So we applied a lot of those tools to how we looked at this building. So we really understood what the problems were. And this was shortly after the History Center took ownership of the building. They had done a great job of maintaining the interior, but the envelope had really been less attended to, one would say. And so we went through and documented where we saw issues with the masonry, with the roof, with some of the wood components, even into the terraces. And we did quite a bit of documentation so that we understood where those conditions were happening and how we could best address them. And you can see the upper right-hand photo kind of shows some really typical conditions we saw. We saw some step cracking. We saw erosion of limestone. We did see some issues with the roofing, with split seams and such. But the thing that was really, I think, important was that there wasn't steel in the walls. So we weren't seeing large areas of displacement or spalling, except for on the 60s edition, which is actually being addressed right now. So taking all that information, we met with the History Center, and one of their goals really was sustainability, and they really wanted to have a sustainable facility that would function, but would also be, contributing back to the community, and at the same time not have a lot of exterior equipment. And that's always the big problem with air conditioning. So when we came to the building, they did not have central air, and so we went through this process of this blower door test. And so we did pressurize the whole building, and we measured where air was moving in and out, and how best to address that. And you can see the photo on the far right is a thermal scan of when the building was being pressurized. And from the different coloration, you can see that there wasn't enough insulation where the roof met the walls. And here you can see on the lower photo how there's a complete void where those two elements meet. The roof had been insulated, but there was still quite a bit of air leakage that had not been addressed. So understanding that, and with a grant that the History Center was so great at obtaining, we were able to put in a geothermal heating and cooling system. And so the illustration on the upper right shows how that system really functions. So we drilled, I think, 16 wells in the east terrace, or the lawn itself. And that's what's really important about having this with such a huge lot. You're able to really take advantage of that space. And so we were able to bury all the equipment, essentially. So we drilled these wells, connected them together, and then brought them into the house where they are tied into a manifold. And then we have heat pumps strategically located throughout, which is what this plan illustrates here. It really shows the different zones of what we were heating and cooling. And then we had heat pumps in the attic as well as in the basement, and in some strategic places on the different floors where they were fully concealed. So it's really important as you put in these sustainable systems that you understand what they look like and how they're going to integrate with the historic fabric. Because first and foremost, you don't want to have any kind of eyesore that might call out, and destroy the historic character of the spaces. So as one of their main goals in having the house air conditioned, it protects a lot of the archives that are here, as well as it made it more usable for events, for weddings and such. And so it was a really interesting and fun project to put forward. We also did a substantial amount of masonry work. And looking at the lower right-hand corner, this was one of the first areas that we attended to first. We're doing some tuck pointing to the masonry as well as the sandstone repair, because that was quite eroded. And this was part of what we put together as part of a strategy to help with fundraising. So in kind of doing a targeted portion of the building and restoring it, using it as a backdrop for photographs and such, it helped spawn some fundraising. People could understand what the building would look like when it was eventually fully restored. And so since then, we've been working our way around. And another big component of that was dealing with the terrace, particularly the east terrace. And we worked on it a couple times in rebuilding stairs and railings in 2 different phases. But really so that acts as a spillover space for the event space. Again, working towards making the center as profitable as possible and as well suited as it can be for the events that it hosts. So this is what we see today. So we did a lot of sandstone restorations and some replacement. The center was very interested in keeping as much material as possible, only replacing the stone where it was structurally compromised. So we did have some decorative elements that were replaced. We had a lot of stone at the base of the building that needed to be cut out and repaired, as well as replaced. And then we had the great opportunity of rebuilding the front porch and making that a very beautiful entrance. And so we are wrapping up right now, Chris. The restoration of the conservatory, and this was actually a 2-phase restoration. The photo on the lower right-hand side shows the walls that were rebuilt. Originally, this was a fully glass-enclosed conservatory. I don't recall when it was removed, but many, many years ago. 1960. Yeah, and so part of the intent here was to restore the design intent of the conservatory without rebuilding it. So we built the low wall with the abstracted guardrail, which was all based on the design of the original conservatory, and that has become, again, another part of the exterior event space. And right now we're in the midst of finishing the sandstone restoration around the main entrance there. So now I'll move on to another project similar in nature to what we've done here at the Dawes House, but this is one that's actually under construction. This is the headquarters for the Cook County Forest Preserve. It was built in the 1930s. It has 2 additions from the 50s, and as part of their mandate, they are striving for net zero. So what we were tasked with, we were brought in actually as a subconsultant to the mechanical engineer who is replacing all the mechanical systems. And as they got into this, they determined that they too needed to do a blower door test to really understand how best to design this building systems. But here you can see they had a lot of exterior equipment. It was all old, and most of it didn't function. So they also had a series of window air conditioning units. And we did several blower door tests. Because of the size of the building, we broke it down into different chunks in order to pressurize it and measure the amount of air that was moving out of the building. And you can see from the thermal scans the various areas that were highlighted, particularly the attic, some joinery around the window, wherever we had the half timbering meeting some of the brickwork, and all the attics needed new and additional insulation. As we got into that, we understood that the windows were one of the biggest leaking elements there. So the Forest Preserve tasked us to do a very extensive window evaluation. And we are not the first ones to do this. GSA, University of Illinois in Champaign, I think there's another agency that have done large window restoration studies and evaluation. What does it cost to restore versus repair or replace? And so we laid out the different levels of restoration they could do and ended up with the right-hand column of that grid showing the pros and cons kind of replacing the windows. We talked with them extensively of if they restore the windows, how they could increase their thermal performance by doing an interior storm, an exterior storm, replacing the glazing with insulated glazing, weather stripping, all those type of basic approaches to restoring a window. And from a performance standpoint, the restored window actually calculated to have a stronger thermal performance and function than a new window would. Because we know with new windows, sadly, they have a fairly quick degradation over their first year once they're put in the wall. And some of it is just the modern materials that they are. Some of it is just that, they're younger, it's younger, softer wood, it won't last as long. And so there's always that saying, once you replace a window, you're always replacing a window. A lot of these old historic windows that are old wood windows can last another 50 years, 50 to 100 years. So unfortunately, the Forest Preserve decided that maintenance was more important to them than the historic material. So we are in the process of replacing these type of windows, these double hung. There's also some casements with aluminum clad wood windows. So we're in the process of working through that mock-up process. And so, Where is that building, that Cook County? Oh, it's in Lake Forest. Right, there's a large park right in the center of Lake Forest, not Lake Forest, River Forest. River Forest, yes, sorry, yeah. And then this is the last project I'd like to talk about today, and this is the Peabody Estate. This is a project we've been working on for the last year and a half. This building was built in the 1920s for a coal baron out in Oak Brook. And the estate was sold shortly after he died, and it was bought by the Franciscans, who added a large convent, a chapel, and a few other things on site. And we were engaged to do a full facility condition assessment and then put together a master plan to bring this facility up to modern codes to deal with their event space and uses throughout, because they use it as a house museum as well as an exhibit hall, and then they have a large performance area. They're very interested in reconnecting with the forest preserve around it, as well as just other sustainability goals. So we are looking at some sustainability systems to really augment the operations. So in going through our assessment process, we worked through their program and helped them understand how their house museum would continue to function, which is in the green, and how the pink, which is their event space. And then we discovered that they had so much extra room in the rest of this convent wing that we're actually recommending they demolish the southern wing in order to consolidate the square footage and just reopen the vista out to the park. So here it shows kind of the overall plan of how that's working together. And we've just started on phase one, which is to stabilize the envelope, do some critical repairs, along with some code issues. But most importantly, put in air conditioning and a new heating system throughout. So where you can see like the blue or the purple is where we're putting in new ventilation. Because as you know, most houses don't necessarily have forced air for code reasons. You can all do that through an operable window, but more commercial facilities require mechanical ventilation. And so as this was built as a house, they relied on that passive system of operable windows, but codes requiring that they have a forced air system. So we are adding little systems throughout the building in order to bring that proper amount of ventilation in. We will be air sealing around windows, putting new windows into the convent wing, as well as doing masonry restoration, new slate roofs, and a series of photovoltaics that will help them move towards a net zero, but not quite to that point. So with that is my quick discussion on what sustainable preservation means. And it's so important that we all start thinking and really moving towards a more sustainable world. And I know having that passive house here in the neighborhood really propels you forward. But what's been done here at the Dawes House, it really sets an example of how preservation can be achieved in order for us to really maintain are very cherished historic properties. So thank you. Any questions I can answer? Yes.
Where in Oakbrook is the Peabody Estate?
That's a really good question. So it is. It's south of Oak. It's on the south side of Oakbrook. I'd have to pull it up on the map, but it's right on the edge of one of the Forest Preserve outings there.
I've been there, but I don't remember where was it. It's in a huge piece of property.
It's a huge piece of property. I want to say it's off of right off of 31st Street. I want to say, but yeah, it's south of the mall, if that helps. Southeast of the mall.
Huge.
Yeah.
Good luck with that project.
Yeah, it's a fun one. Oh. Yeah.
Just a question on heating systems.
Sure.
Only because the house we had in another part of the country had a gas-fired boiler
Yes.
with radiators.
Yes.
And I got really into reading about them, and Heating Help was a book. And
Yeah.
how do you deal with those systems which were designed, as they say, by the Dead Men Society? Because the people who actually built these radiator systems are no longer with us.
Right.
And so many of them were put in when windows were not really good
Correct.
at sealing air out. So many of them are oversized for the buildings they're in.
Correct.
I mean, how do you evaluate and work through all that?
Well, often, because my husband and I actually had a radiant system in our house. We had a Victorian home from 1912, actually, and it had a radiant system, and all the radiators were overheated. And we actually turned that down. You can adjust the valves, right, in one way, but you can also upgrade the boilers so they're much more efficient. Insulate the piping that runs to the radiators, so only the radiators themselves are the ones that are radiating and not all the associated piping. And then you can introduce additional systems like Space Pack or Unico. They're high velocity air conditioning systems. They can be air conditioning and or heating. And those are excellent systems that can be put into the attic or the basement, and then these small tubes are then run. And as long as it's designed correctly, there shouldn't be any air noise issues, but there are ways around that. And whenever, any projects that I work on that have a radiant system, we do recommend that they keep them because they're really great systems. And once you get used to how they function and their comfort level, you understand how you can manipulate them to your preference.
Thank you.
Sure.
I wanted to ask about
Yeah.
the blower door. This might be a silly question, is there any way to DIY mimic that to find where the air is leaking?
I don't, doing a blower door test isn't that expensive to do, actually. So if you want to do it, I would encourage you to do it, to find a vendor that does it, because with the passive house, they're doing it all the time in order to get those homes certified. So I think the cost to doing a blower door test has really been reduced. And particularly if you're looking at a house as opposed to a mansion, it's going to be more, it's going to be easier to do. And you still might have to zone it and shut down certain rooms in order to focus on areas that have problems. But otherwise, ways I've done it in the winter is you wait till it's really cold out and do a smoke pencil test. You can buy those from Amazon. I think a pack of 12 is less than $10. And you light them, and then you can just go around your windows and see where it's leaking. You can go to penetrations in your ceiling to see if those are leaking in and around ductwork, particularly for a toilet exhaust if you have something in the ceiling. Any of your second floor ceilings, and even around the perimeter where you have, the rim beam, that's another point where you'd see leakage. But if you do want to do it yourself and not pressurize the building, I would recommend a smoke pencil test in the dead of the winter. Yeah, sure.
the specific passive house that we're talking about in Evanston?
I am not.
I don't know that much about it, but it was an empty lot for years and years, and Chris knows more, but the woman that had it built with an architect here, they've done a program too, but yeah, that was the house that Chris was talking about, is like being in a submarine, and we went and toured it because it is going to be on the house walk. And I was just wondering how many homes are to that degree, but you're not familiar with that.
Yeah.
I mean, she doesn't have any, she has no fireplaces.
Because they leak.
Right.
Right.
So, yeah, I get the impression that that one is kind of the pinnacle of.
Yeah.
I mean, it's passive, because it's like passive is like the top of the top, the ultimate, right? It's not, it like blows lead out of the water. It's just.
Yeah, it does.
Every detail of that house, the carbon cure, or I mean, the stuff they used in the basement has low carbon concrete. They used a smaller basement so that they didn't have as much, concrete. Triple pane windows. I mean, it's unbelievable.
Yeah, and the whole thing, modern technology now is this exterior continuous insulation, right? So the house may look like a regular house, but the insulation's on the outside. It's not in the studs like we traditionally build here in Illinois. It's on the outside. And that's where they really then get the performance, because it's continuous, right? The idea is to prevent thermal bridging, because that's another big problem with historic buildings, because we have everything that ties everything together, and you know how heat just gets sucked through solid material, and so as things are connected, things are pulled through. But with the thermal, the exterior insulation, it prevents that from happening.
And then on top of that, they try to make it, and they get into a historic block.
Yes.
Because that challenge.
Yes. And, as the world has been going towards more glass, that's less sustainable. I think the passive house is coming back to more reasonable openings. They usually want to see about 35 to 40% glass within a wall. And that all helps the building be more thermally performing. Sorry.
What was the house you were just talking about? I couldn't hear.
Oh, the one with it was just a general statement about sustainable technology. Oh.
Passive house here in Evanston.
Is that 1210 Maple? And it's going to be on Tesla.
Make sure you check it out.
If anyone wasn't able to attend the talk, we do have the talk available on YouTube, so you can pull it up there and watch the talk on the passive house.
I'm also curious about the conservatory work on the house here. Is there, it sounds like it was a very intentional choice not to rebuild the glass. Can you elaborate on that? Like why?
That is a financial choice for starters. Yeah, because there's some sandstone and glass roof and glass windows, but it was mostly that we were trying to address, and Ellen should remember, that when it was demolished, it sort of left part of the foundation vulnerable, and we were getting a little bit of leaking in the basement from where it was. So we had all the original blueprints. So Scott looked them up, and so we replicated the floor to the original blueprints. And we just someday
Someday.
when someone gives us a couple $1 million and says rebuild the rest of it.
Yeah, but that's a good interim step, right? Because it still interprets that there was a conservatory there. You can understand that it was there, and it's a very typical preservation approach to kind of do that interpretation for something that's been demolished. Yes, sir.
We're in a situation where the client isn't ready to go to net zero, and you're only going to go partially to net zero. Are there discussions around, well, if you spend this little bit more, then the next time you come to it, it's going to be easier? Are there like ways you get halfway there that are better than other ways that you get halfway there?
Yeah, we show them payback, like their return on investment, and so we can project that out based on what their energy costs have been in the past. If we put in different systems or do different levels of insulation, we can demonstrate through the energy model what those savings would be. both in energy, which then translates to dollars, and we can talk about how long that would take in order for them to earn back the extra money they may invest in a more sustainable system. And so those are all really good tools to help the owner understand that they're not just investing money without any return.
I was asking more around what you end up doing. Are there different ways to kind of get to an end that might cost a little bit more now, but have a better payback?
With different systems, yeah, and it so depends on the situation you're looking at. There's so many different options that need to be evaluated. We often start with the mechanical systems because those are the most expensive, and we layer on what it means to then apply, new windows or additional insulation, and we outline all those scenarios so the owner can understand that. But it's so site specific. It's really hard to talk about because you could have 10 different options for one building.
I mean, the thing you mentioned earlier about dealing with the insulation before you deal with the mechanical systems seems to be a general rule that you don't want to start with the mechanical systems and have to build them bigger than ultimately
Correct.
they have to be, right?
Yeah, correct.
Are there other rules of thumb that are kind of as obvious or
Yeah, because that's the most obvious. It's always best to button up the envelope of the building before you replace the systems. We have clients that do exactly the opposite. Like we're working with, again, another project with Cook County where they're replacing mechanical systems per floor for the county building downtown. And we're tasked to evaluate and replace the windows. I mean, they're historic windows from the 60s, but they want to replace them so they're higher performing because they are. They have zero U value. It's almost like an empty hole in the wall. And so, but they're opting to put in mechanical systems first to get immediate comfort and then spend the time to evaluate the envelope. And they're just doing it, incrementally as they're kind of restacking the building and shuffling around the tenants. So it's very, it can be very challenging depending on what, who the owner is, what their users are. A house versus a commercial building are totally different. With a house, I would always recommend that you do the envelope first. But, my husband and I, on our house, we did a lot of stuff in the order that we wouldn't recommend our clients to do. So it's very personalized. Yes?
What do you do when you, with that example where you have historic windows that are going to be replaced, do you encourage your client to reuse them somehow, give them to a rebuilding exchange or other place that could reuse those materials so they're not going to a landfill?
Yeah.
So kind of furthering the sustainability.
Yeah, there's a handful of groups in the area that actually come in and will salvage stuff. Or you can require it within the contract documents that the contractor salvage that material and resell it to one of these salvage companies. That's always something that could be done. We do encourage that. And a lot of these materials are, kind of renewable, like the county building has steel windows. And so that steel is naturally renewable and recyclable, so that will be recycled. So we do as much as we can to divert things from the landfills. And one thing I didn't really talk about was LEED certification itself, because very rarely do we go for LEED certification on these historic projects. It's challenging to meet all their criteria, and it's also expensive. And so, LEED is great to have associated with your building, but it's really over the 25, 30 years that it's been practiced, it's become more and more standard operation. So their goal of changing the marketplace has really occurred. So people are naturally building more sustainable buildings because they're more cost effective. So reaching for that LEED certification may not be something that's actually beneficial from a cost standpoint, but it is a great marketing tool for some organizations. Yes?
I'll just add a little bit to this conversation about the radiant heating. We lived in a 1970s Victorian row house in Brooklyn. Had a one-pipe steam system that actually worked beautifully. Very simple, and it was adjustable. But we also relied on the natural draw through the house with a attic fan to pull the hot air out, and ceiling fans, and it was quite comfortable. I think, to what extent, when we put the emphasis on sealing the windows, and particularly in the case of historic houses where you're putting a storm window that makes the window less operable, if you're retaining original fabric and that type of thing, to what extent are we losing the capability during the swing seasons to not have the systems on, to rely just on a little bit of support in terms of the heating, but instead, relying on forced air circulation and ventilation constantly. Our neighbor running the system all year round, 24 hours a day, no change. To what extent is that consuming more energy than the loss that we would have had at the window? So, we need to restore passive techniques, and we're in such a wonderful location by the lake to capture those breezes. But I just find people don't even think about, if you put a window over here, it'll pull the air through the house at night, bring in the cooler air from the garden, exhaust it through the ceiling. We're sort of losing that in this whole conversation.
We are, that is true. But there's also storm systems out there that allow you to remove the glass and swap it out with a screen, and so you can take advantage of those shoulder seasons when it's really beautiful out and you want to open the windows. But then you can easily, reinstall that glass from the inside. And so there are systems that are really effective like that. And it still, looks appropriate. It's a storm window that's appropriate to the building. And they work really well. There's other ones where you can actually pop out the storm. So it's, I think it's more like a French window, when you say. So it's like, it's pinned at the top and you can pop it out at the bottom and you get the ventilation around it. It's not as much as if there were no storm, but there are ways that you can still maintain that kind of passive ventilation. But it needs to be thought of when the windows are being designed. You're right, you shouldn't just think about when we need it completely buttoned up when it's super hot or when it's freezing cold. You do need to understand that those windows should be operable.
Is where they're building all these new buildings and with flat facades and flat, no recessed windows and no eyebrows to block the summer sun, which can be very effective in cutting the sun,
the glare,
the height of the summer.
Right.
It's just not part of the thinking yet.
Right. And also, and some of it too isn't just the protection from the sun. Some of it too is water shedding, right? If you have a very flat wall, water's going to run all the way down it as opposed to drip off like it does at a window head or a window sill, which helps, or even at the, the eave of the roof, which helps keep water away from the walls. So yeah, there's a lot of things that they knew how to do really well that we've kind of forgotten, and I think we're rediscovering.
Thank you, Ellen.
Yeah, thank you. Thank you.